and our topic is swapping of two numbers. Contents are introduction, a problem statement, objectives, implementation, core, algorithm, conclusion, and the future scope. My part is introduction. Swapping of two numbers is one of the basic and the most important operations is microprocessor programming. It means exchanging the contents of a memory to memory locations without losing the data. In this experiment, we are using 8085 microprocessor to swap the data stored at the memory locations at like 78H and 79H. This operation shows how the accumulator and the registers can be used efficiently for data transfer using the instructions such as MOV means move data, LDA means load accumulator direct, STA means store accumulator direct. Understanding these instructions helps us to build a foundation for a complex data manipulation and the memory operations in a microprocessor system. By performing this program, we also learn how the accumulator works as the central unit of the data transfer and the registers acts as a temporary storage during this program execution. The next part is problem statement. We need to write a ASCII language program for the 8085 microprocessor that will swap the contents to memory locations 78H and the 79H. The content should be exchanged efficiently using the registers without losing the data. The program should move the data from the memory into registers, exchange the contents, and store the swap data back into the memory location. After the execution, the data originally at 70H should appear at the 79H, and the data originally at 79H should appear at the 78H. This confirms the successful swapping of the operation. Next will be continued by the Apu.
Thank you, Amrita. My part is objectives. Objectives to be explained to understand how to transfer and manipulate data between memory and registers. Here we learn how data moves between memory like 78H to 789 and processor registers. And the second objective is to learn the process of exchanging data bytes using MOV instruction. The MOV instruction is used to copy data from one register memory to another. And the next objective is to demonstrate register-based data swapping in 8085 microprocessor. Show how register like A, B, and C can be used to swap two values. And the next objective is to verify the correctness of swapping through output observation. Here, after execution, check the memory values to confirm that they are swapped. And the next objective is to demonstrate how accumulator and registers are used for temporary storage during swapping. The accumulator A and another register like B or C hold temporary data while swapping values. And the sixth objective is to observe memory register data flow during swapping. Understand how data moves between memory and registers in swap process. And the next objective is to understand data exchange between two memory locations using registers. Swapping requires reading values into register, exchange them and storing them back. And the next objective is to learn data transfer instructions like MOE, LDA and STA effectively. LDA loads data from memory to accumulator, STA stores accumulator to memory, and MOE transfer between registers. And the next is implementation. This part explains step by step how the swapping is done in the microprocessor. Algorithm steps are explained here. First, we need to start the program, begin writing the assembly code and initializing the microprocessor. And the next step is to initialize memory locations 78H and 79H with data like 45H and 32H. These are two values you want to swap. And the next step is to load the first data byte 78H into register A accumulator. Use instruction LDA 78H. Now A is 78H. And the next step is to load the second data byte from 79H into register B. Use instruction LDA 78H after storing previous A or use MOE instructions. Now B is 78H. And the next step is to exchange the contents using the temporary register C. If needed only, temporarily stores one value in C to swap them correctly. For example, move A to C, move B to A, move CA. Originally from 79H into 78H. Use STS 78H. Now memory at 78H is equal to 79 from 78H into 79H. And next is to stop the program. Use HLT instruction to end the execution. In simple terms, you are writing an assembly program that takes two numbers from memory, swaps them using registers A, B and possibly C, then stores them back into memory at their swapped position. Thank you. Next part will be continued by Aditi.
Thank you, Apurva. Now I will go through with the code explanation part. The code demonstrates how to swap two data bytes at memory location, that is 78H and 79H, in an 8085 microprocessor using registers and accumulator operations. The first step is initialization. MVIC 00H clears register C, which will be used as temporary backup. This step is optional and just ensures C starts with the knowing value. The step 1 is LDA78H loads the value at memory location 78H into accumulator, which is taken as A. Move B, E. Saves the value from the accumulator to register B, acting as the first number, as in a backup. The step 2, which is LDA79H, fetches the value at memory location 79H to the accumulator second number. Move C, a backup up this value to register C. This is optional. Now, because it is shown in the illustration, STA78H, which stores the value currently in the accumulator, which is from the 79H taken, to the memory location of 78H. Step 3, move A. B retrieves the original 78H value from register B to the accumulator. STA79H writes this value to 79H, completing the swap between 78 and 79H. Optional step, which is the verification step, which we call, loads the swapped values from the memory into registers D and E for checking or input or output. The end is HLT stops execution. The sequence memory register data flow, memory location 78H first number, which will go to the accumulator, which will go through register B. Then the memory location 79H, the second number, which will go to accumulator, which will register to C, and that is actually optional. And then the accumulator, which is now the 79H's value, will go to memory of 78H. Then the register D, which is the original value of 78H, will go to accumulator, then to the memory of 79H. The final check is memory of 78H will go to accumulator, which is D. Memory of 79H will go to accumulator, which will be E. Move instruction usage, which is move B, A, moves the value from the accumulator to register B. Move C, A as same as B and D. And move A, B moves the value from B to accumulator. Move D, A and move E, used for verifying and swapping of the result. As the verification part just said, the result will be 78H is equal to 42, which will be in decimal form. 79H is equal to 85, which will be also in decimal form. The registers D and E after step 4, which will be swapped. Then the conclusion of this code is the attached highlights the simplicity and effectiveness of using registers to swap memory values. It shows how the accumulator acts as an essential intermediary for all data movements in the 8085, ensuring clear and efficient data flow between memory and registers. The code is modular, easy to trace, and demonstrate assembly logic for similar programs. Thank you. The next part will be continued by Bhavna.
Thank you, Aditi. Next is swap the numbers stored at memory location 78H and 79H, in which this program shows how to exchange data between two numbers to location using 8085 assembly language. This program swaps two numbers stored in memory location 78H and 79H using 8085 microprocessor instructions. First, we load the number from 78H and save it temporarily in register B. Then we load the number from 79H and store into it 78H. Finally, we take the saved number from B and store it into 79H. This way, both numbers exchange their places. The program ends with the halt instruction. This demonstrates data transfer memory and handling using register in 8085. Next is future scope. In the future, the swapping technique can be used to develop first memory management. System is embedded devices and firmware. It also helps in creating efficient data handling algorithm for IoT and robotics where memory is limited. We can apply the same concept in operating systems and device drivers for better performance. Overall, this project builds problem solving and optimization skills, and it forms a strong base for learning advanced microprocessor and assembly programming in the future. Thank you so much.